Empire Total War, really popular game, RTS kind of a game. This is an example of actually just a pretty traditional engagement from NVIDIA with a game developer. Most engagements from NVIDIA are just generally, let's make the game better. You know, or they may have some issues or some bugs or performance. So there's no physics in this, there's no, nothing special or different, it's just, let's make the game better. So we did a bunch of application improvements, fixed a bunch of bugs, implemented a new feature and inclusion. And this is actually more of what we do than physics kinds of engagements. We do a lot of these kinds of things. So we engage with the developer, and there's a huge number of improvements we can make to their engine and their pipeline. So the first thing we do is we get their code in, and we profile it. And we get a really good understanding for how the rendering pipeline looks. Sometimes we'll actually just get the code and go through it, although sometimes the code's so complex that you need to use tools to profile it first. And they were doing some double rendering things, taking extra passes when they didn't need to. We did a Z pre-pass, so that one of the reasons you might want to do a Z pre-pass is that the final visible pixels are the ones you want to spend all your time polishing with shaders and stuff like that. Whereas if you don't do that, you might spend a lot of shader horsepower on pixels which were included. So we implemented things like that, fixed some shadow mapping, provided a whole bunch of suggestions for how to improve their LED behavior, both from a performance perspective and a kind of a popping perspective. Fixed multi-GPU scaling. That's a pretty common problem. The first time a developer implements something, a lot of times they'll do things like a lot of extra texture copies sometimes that foil multi-GPU implementations either from NVIDIA or ATI, so we fixed that. Improved memory optimization, so you didn't need necessarily a 2 GB frame buffer to run at high resolution. Let's see, oh yeah, the vertex buffer updates, improve that kind of stuff. So we wrote a bunch of code for them. We rewrote their detection thing. We fixed some shaders. We implemented ambient occlusion. This is an example of an interaction with the developer that was really useful both for us and for them. I think the first thing is, along the way, all of these things that we do when we write code for a developer, we write the code and then we walk the developer through the code, so we're teaching them. Right? That's hugely beneficial for everyone because now that developer can go off and do cool stuff by themselves the next time. The other thing is we learned a lot about how their engine works, the kinds of things they were trying to do. They were trying to use DirectX in some fairly novel and innovative ways, and so we got a good understanding for that kind of thing, which we can then kind of roll into, well gosh, this developer was really trying to do this with DirectX, but they couldn't, or it was really, really inefficient. So we can either change the API or change the hardware to solve for those kinds of things. It's really good, both kind of a two-way interaction. So there's kind of two main modes. There's the land and the sea mode for the game if you haven't played. So here's some examples of performance. So this is kind of when we first got going, and this is kind of 3 months later, roughly 4 months later after we were done. And you can see from a performance perspective outside, we kind of improved performance by 60 to 80%. And probably more important is the frame rate went from the 20s into the 40s and 50s. That's a pretty substantial improvement. The other thing, of course, is we implemented anti-aliasing for us at all, but we substantially improved the performance of anti-aliasing for ATI, right? Roughly doubling it, well, in some cases. This optimization here, where their performance improved by a factor of 12, that was a multi-GPU and a memory fix, right? That's, I don't know what the word for 12x, it's not, not order of magnitude, it's we 12x in ATI's performance. Kind of the same thing down here. Again, roughly from 2x to 30, 40, 50%. Some of the optimizations that benefit some architectures don't always benefit others. So in this particular case, actually the 9800 GTX actually didn't get faster in the C mode, but the anti-aliasing cost is pretty low. Right? You can see. So this is a pretty common thing. We go to work. We're just trying to make the game better, improve the frame rate, and the world benefits. So I've shown you kind of quite a number of examples now of first get the code, go to work, a few months later, bang, roughly a 50% to 2x improvement in performance. Plus we implemented some new features. So I guess the way that I'd like to kind of summarize or conclude is the goal for the group is to make the PC experience as great as it possibly can be, as differentiated from the console as it can be, and even independent from the console. We really just do want to make great games. When the guys like Crytek do Crysis, we love that kind of stuff, right? When Far Cry 2 shipped, that's just fantastic. When people are pushing the state-of-the-art, moving things forward, that's a wonderful thing. I think it makes the visual experience of the game are enjoyable, but we just want to help make great games. We all love to play games. I'm a gamer. You know, not quite as well. In some games, I can compete with him.
How many level 80s you have?
Let's not even talk about that. But in an FPS, he'll clobber me. And then, of course, the other thing that we want to try to do is provide a differentiated experience to NVIDIA whenever we can. Not an exclusionary experience, but we want people to have as great an experience in NVIDIA hardware as they possibly can. So things like 3D vision, things like physics, features which are cool. They should have a good experience. And just even beyond differentiation, the quality should be good, the out-of-box experience should be good, there should be no bugs, people should be able to buy the game, play it in NVIDIA, get a great experience. That's what the group is all about, right? If we're doing our job, people should feel like gaming on NVIDIA is just a great thing to do, and hopefully we'll sell a bunch of GPUs. Right? If we're doing our job, people will feel like the PC is the place to game, and they'll buy us, when they can, they'll buy PC versions of games. When we're doing our job, the PC and the technology itself will continue to kind of move along, and the state of the art will continue to be pushed. And just like, in my opinion, Avatar is one of the most technically amazing movies ever produced. We want to keep doing the same kind of thing in the PC. We want that level of innovation to happen for games, and make games just awe-inspiring every time. So that's the summary of the group and the technology and the content group. Do you guys have any questions? Any games that you have some questions on, or things that you think that you want to know about the content group? The thing we have after that actually is some performance and some demos, and I want to make sure we save some time for that. But if you have questions or thoughts, I'm happy to ask. Or any of the guys here. You got Evangelist, the guy who runs the gaming and gaming technology group. Good? Yes? So so what do you guys think? Is it a good thing? We invest a lot in this. Do you guys feel like it's you're seeing a benefit? Is it worth it?
Yeah. If the technology is being developed, if you guys put it, work with the developers to bring new things about, then sure, definitely.
Is there things you would change?
Not being a developer, I would say.
How about as a gamer? It's really important that, like I said, we want the gaming experience to be great on the PC and especially great on NVIDIA. So if there's things that you would change, what would they be? I'm here gathering feedback so we can go make it better. Wow. Did that go?
Not sure.
It's a very open question.
Yeah.
Very unspecific.
Yeah. All right, it's all right. We don't have to go there. So why don't we go over and gather around Lars now, and we're going to take a look at I think Far Cry 2 as an example of graphics on GF100 versus GTX 35. Dark Void as a physics example,